Welcome. Today we will integrate an expansion unit with your host server. This configuration expands your available PCIe slots, allowing your system to scale for high-performance computing tasks. We rely on three main hardware components to establish this link. The HBA host adapter installs inside your server, while the HBA target adapter sits inside the expansion unit. Both connect to the backplane, which physically houses your PCIe devices. Looking at this OSS 580 backplane, you can see the central Broadcom PCIe switch chip. This chip functions as the traffic controller, managing the flow of data across multiple lanes and slots simultaneously. Understanding this traffic topology is essential. It allows you to add high-density I/O capabilities directly to your host machine without creating internal data bottlenecks. Before making connections, identify your specific expansion unit model. You are working with either the standard Gen5 4UP or the Gen5 4UP Max. The models differ primarily in cooling capacity. If you have the 4UP Max, your unit requires a dedicated 3600-watt power supply strictly to run its three 400 CFM cooling fans. You also need to confirm your backplane slot capacity. Depending on your configuration, these units provide either 5, 8, 10, or 16 available PCIe slots. For 10 or 16 slot configurations, the system uses two backplanes. As shown here, the primary backplane is physically linked to a secondary board using these daisy-chained ARC cables. Confirming your model and slot count now ensures you have the correct power and cabling setup for the rest of the installation. To begin the physical installation, seat your PCIe devices, such as GPUs or network cards, into the downstream slots on the backplane. Connect any required auxiliary power cables at this time. Next, install the HBA target adapter. This card must be installed into the designated upstream slot on the expansion unit's backplane. Now move to your host server and install the HBA host adapter into a compatible open PCIe slot on the motherboard. We can now connect the two systems. With OSS 595 adapters, the physical connection requires a single CDFP link cable to bridge the host and target cards. If your setup uses OSS 579 adapters, you must use two separate QSFP-DD link cables to establish the connection. Inspect the link cables to ensure the connectors are seated completely flush against the card brackets and that the release pull tabs are lying flat. Correctly seating the cards and matching the cable count to your specific HBA model prevents link failures during the power-on process. You must follow this absolute rule for the boot sequence. Power on the expansion unit before you power on the host server. During boot, the host server BIOS scans the PCIe bus to identify all connected hardware. The expansion unit must be active for the server to recognize it. If you boot the server first, it will not detect the expansion unit hardware and will fail to allocate the necessary I/O resources to those devices. Following this exact sequence, unit first, then server, prevents the most common cause of hardware setup failure. Once the systems are running, verify the physical connection. Check both HBA adapters for illuminated link status LEDs, indicating a valid connection. To verify detection at the operating system level, open a terminal on your host and run the lspci command. Search for vendor ID 1954 to confirm the OSS devices are present. If the devices do not appear, power down both systems. Reseat all link cables and PCIe cards, then perform the strict power-on sequence again. If you encounter fan or power issues on a 4UP Max unit, ensure the dedicated 3600-watt fan power supply connects to a 230-volt AC source. Confirming the physical LEDs and the terminal output ensures you have a verified, stable hardware link. When your terminal list populates and the link LEDs remain solid, the server has full control over the expansion unit. This completes the hardware integration. You can now proceed to install the specific software drivers for your GPUs or NICs to begin utilizing the hardware. Pairing the correct physical topology with a strict boot sequence ensures reliable communication and enables the full performance of your host server.